So let's talk about precipitation reaction, and this will close out this section here. So, what do we mean by this particular term, precipitation in chemistry? Well, basically, precipitation is said to occur when you mix two solutions together and you have the spontaneous formation of a solid out of that combination, out of that mixture. All right? So, an example is shown here. This is a reaction between, I think, if I'm not mistaken, the reaction between lead 2 nitrate, let me write this down here, lead 2 nitrate and potassium iodide. Right? Now these two compounds are dissolved in water, so they're both in aqueous solution. And the product of this reaction is lead 2 iodide plus potassium nitrate. All right, aqueous. And to balance this correctly, we're going to need a 2 here and a 2 here. All right. So in this particular case, you're mixing this solution with this solution, and you're going to end up with this compound, which is a solid. So this pale yellow stuff that you see here in the test tube is the lead 2 iodide being formed out of solution. All right. And we can actually make predictions as to whether or not a solution would be formed. Now, first, before I do that, let me just point out that you may recognize that this is an example of what we call a double displacement reaction. If you remember, a double displacement reaction is where you have an exchange of ions between two compounds, two ionic compounds. So the lead is replacing the potassium, and the potassium is replacing the lead. And that's how we end up with these two products, lead 2 iodide and the potassium nitrate. All right? So this is what you'll find in some precipitation reactions. In fact, I would say all precipitation reactions involve, no, let me not say all, but most precipitation reactions will involve some sort of double displacement taking place. And we can actually make predictions as to whether or not a precipitate will form, right? So let's say you're given a question where you're given two solutions and you're asked to make a prediction as to whether or not a precipitate would form. Well, we can do that if we use what we call solubility rules. So this chart that you see here is basically giving some rules, call them a solubility rules. All right, and these basically gives you information about what type of ionic compounds will be soluble in water and which ionic compounds will not be. So, for example, it says here in the first line, almost all nitrates, acetates, perchlorates, and group 1A metal salts and ammonium salts are soluble in water, right? So any compound that fit this description, you can assume that those compounds will dissolve in water. And then the second line here says most chlorides, bromides, and iodides are soluble, but there are some exceptions. Pb2 plus, Ag plus, and mercury 2 plus, right? Any bromide, chloride, or iodides that's combined with lead 2 plus, silver plus, and mercury 2, well, this is actually mercury 1, those compounds will be soluble or would be insoluble if they're combined with these, all right? And there are some other descriptors that are given below. And basically, if you use this chart, you can make predictions as to whether or not a particular ionic compound would be soluble in water. And therefore, based on that, you can tell whether or not a precipitate would form, because basically precipitates are compounds that do not dissolve in water. So if you can make a prediction that a particular compound, based on these rules, would not be soluble in water, then that compound would form a precipitate from the appropriate solutions that is used to make that compound. So before I move on to an example, these are just some applications of precipitation reactions that is used in a lot of industries. For example, the first one is used for water purification to remove any dissolved aluminum ion present in an aqueous solution or in any water source. This is used to remove phosphates from wastewater when it comes to sewage treatment, and so on and so forth. All right, so these are just some applications of precipitation reactions. Now, I want to move on to an example. Let me get out of this here. So let's say, and I'm going to use the example that we saw before, the reaction between lead 2 nitrate and potassium iodide. So let me get rid of this here. And I'm going to write down the formula for lead 2 iodide. I'm sorry, lead 2 nitrate, which would be in an aqueous solution, and potassium iodide, which would also be in an aqueous solution, right? Now, based on the solubility rules, we know already that lead 2 nitrate and potassium iodide are soluble in water. Let me go back to the rules and show you exactly what I'm referring to. So, okay, so these are the rules right here, right? We know that lead 2 nitrate is soluble in water because it says here almost all nitrates are soluble in water, right? And not only that, well, let me leave it at that, right? So nitrates are soluble in water. So pretty much any nitrate or any compound containing a nitrate ion will dissolve in water. We also know that potassium iodide is soluble in water because it says here group 1A metal salts. Potassium is in group 1A, so therefore any ionic compound that is formed with potassium would be soluble in water. Not only that, but we know also that most chlorides, bromides, and iodides, right, so potassium iodide would be soluble in water as well for that reason because it contains the iodide ion, right? So that's just how we use the rules to make predictions as to whether or not a particular ionic compound will dissolve in water. Now, let me go back to this right here. So you could be asked to write down a balanced equation for this reaction. So this would be, as I said before, a double displacement reaction. So we know that the lead will come together with the iodide to form lead iodide, and the formula for lead iodide would be PbI2, all right? And in the case of potassium coming together with the nitrate, it's going to form potassium nitrate, and the formula for that would be KNO3. Now, the next thing we may be asked to figure out is, will a precipitate form? And the answer would have to lie in whether or not these compounds would form a solid, or these compounds will not be dissolved in water. So we have to go to the chart and make a prediction as to whether or not lead 2 iodide or potassium nitrate would be soluble in water. So if you go to the chart, let me go back here, right? If you go to the chart, dealing with potassium nitrate, we can tell that potassium nitrate will be soluble in water because potassium is a group 1A metal salt, right? And it says all nitrates are soluble in water. So therefore, we can say that potassium nitrate is soluble, and therefore we put AQ to indicate that this is an aqueous solution being formed as far as the potassium nitrate is concerned. Then now we look at the lead 2 iodide and see if we can make a prediction based on the chart here. And according to this, most iodides are soluble, but here we have an exception. The exception would be any of these compounds, any of these ions combining with Pb2+, all right? So therefore, we know that lead 2 iodide will not be soluble in water, and therefore, because we know it's not soluble in water, we're going to put S for solid, meaning that a precipitate would form, all right? So that's basically how we make a prediction as to whether or not a precipitate will form, all right? Now, let me make sure that this equation is balanced. We need a 2 here, and we need a 2 here, all right? Now, what we're going to do next is figure out what the net ionic equation is, right? So this would be the molecular equation. If you remember what we did when it came to the neutralization reaction, we did the same thing. The first equation would be the molecular equation. And the next step now is to find out what the ionic equation is. So if you remember what we did previously, we examined each of these to see whether or not they would form ions in an aqueous solution. Now, remember this, and maybe I should write this down somewhere here. Let me write it up top here. Aqueous, how should I put this? ionic compounds in aqueous solutions will dissociate to form ions. All right? Key thing to remember when it comes to these reactions, right? So any ionic compounds that is in an aqueous solution will form ions, all right? So let's start off with the lead 2 nitrate. Lead 2 nitrate is ionic, it's in an aqueous solution, so therefore we know it's going to form Pb2 plus aqueous plus 2NO3 minus aqueous, all right? So that's what happens as far as the lead 2 nitrate is concerned. It will break up to form these two. Potassium iodide is also aqueous and it's also ionic, so that will dissociate as well. Now you'll notice there's a 2 here, right? That 2 will multiply both the potassium and the iodide. So therefore when that breaks up, you're going to have 2K plus aqueous plus 2I minus aqueous. All right, and that takes care of everything on the left side of the equation. And then on the right side, we have to look at what happens here. Now on the right side, we have lead 2 iodide, but it's in a solid state, right? So because it's in a solid state, that means that it will not break up to form ions. So therefore, we just simply rewrite that as it is. And then when it comes to the potassium nitrate, it's ionic, it's in an aqueous solution. And again, please note there's a 2 here, which multiplies everything within that equation. So you're going to end up with 2K plus aqueous plus 2NO3 minus aqueous, all right? And that is basically the ionic equation. Now, again, referring back to what we saw earlier when it comes to the neutralization reaction example that we looked at, remember that in order for us to get the net ionic equation, we have to cancel out common ions on both sides, right? The identical ions on both sides we need to cancel out. And if you examine this ionic equation carefully, you'll see that we have potassiums here and here, so those will cancel out. And we also have the 2 nitrates here canceling out with the 2 nitrates here, all right? So basically, the net ionic equation will be what is left, which will be Pb 2 plus aqueous plus 2I minus aqueous, and the final product would be PbI2 solid on the right side. And this would be the net ionic equation for a precipitation reaction. All right? Okay, so much for